vote things if you also want that same question answered. And I'll relay those, whatever questions are in the Q&A window, I'll relay those to Lars myself, but you can also ask yourself, you just raise your hand and I'll unmute you. And then later on in the presentation, we will we'll open up the floor if people just want to have an open discussion about what was presented. So that'll be after Lars has presented his slides. So with that, Lars, you can take it away.
Okay, thank you, Katie. So thank you all for coming to this strange new world of conferences where we don't move around. So I assume it's nice weather in Denver. And what I wanted to go into today is briefly talk about the background for reproducibility activities in economics, in the social sciences. My background is obviously in economics, and I will be speaking mostly of that, but some of these activities and tendencies are present more broadly. So I want to give a brief background on why we are doing this, why this is necessary, make a note of the various elements of progress that we've had going forward, and describe some of the challenges as we go about this. I'll then pivot about halfway through the talk into what have we learned after a year of doing this, and I'll be clear about what this means, and provide some practical guidance on 3 themes which are recurring in reproducibility attempts that I've supervised. So my view on why this is a necessary activity to think about and to be active in the terms of reproducibility is that we have a fundamental shift over the last century in how we communicate scholarly knowledge amongst scientists. And if you go back and actually look at early publications, and I encourage folks to do that, whether you can walk into your university library again anytime soon, or whether you do it electronically, go back and look at early publications, because many of these themes that we're going to be talking about were already present back then. And one of the key themes is availability of the data that underlies scientific conclusions and the necessary logic, calculations, math that is necessary to go from raw data to some scientific conclusion. And over time, data became electronic and math was transcribed to code, and that led to a shift in the way we do science without the same shift going on in the publication world. To some extent, some of this could be put under the guise of big data, because if we sort of go back into the early 20th century, what I'm showing you on screen is actually the data supplement, is what we would call it today, for an article in the early American Economic Review. It was simply printed, and because it didn't fit, they folded it out as an insert that literally was part of the publication and was pointed out. But these are not humongous numbers, so there's a couple of more columns that just didn't fit, and all the math can be done by anybody who's out there, and it's outlined in the article, etc. As we move to more modern publications, if you are still looking at most of these, even though they might be a bit fancier in a browser, they might have a bit other stuff, we don't have that same amount of transparency. We're still mostly stuck with electronic versions of dead wood splattered on the screen. And so modern publications need some of the same transparency and completeness as in the old days. The attempt to do that were data supplements and other things, and I'll get to some of the shortcomings of that. And when we talk about reproducibility, replicability, transparency, and that topic, what are we actually talking about? So I like to start the talk by defining what it is that it is. That is necessary because there's various ways that these terms have been used, and it matters when you actually start to dig down into what you actually call it. So I conceive of this as a replication continuum, and we're going to use generically the term replication. That seems to be the more usual one, but I'm going to refer to an emerging consensus on how to specifically define some of these terms. The latest version of that is a report by the National Academies released last year on reproducibility and replicability in science, but it picks up on similar definitions earlier on by NSF panels and other things. So reproducibility, often augmented by the adjective computational reproducibility, is literally what you get when you redo the analysis that's been posted in the paper using the same data, the same code, the same methods, the same context, okay? And I'm gonna put these 4 dimensions, data, code, methods, and context up there as sort of a guideline, but they're not the only ones to necessarily think about. So think of this as literally what we're seeing in front of us. I can reproduce if I have the same data, the computer programs that the author had, etc. They didn't make a typo in transcribing it. They didn't transcribe something that isn't there. It is well defined, and I can understand how they got to that result, right? So there's still a lot behind this. Replicability is, in this definition, a bit broader. We're going to relax some of that criteria. So we're going to potentially use different code or software. We're going to, for instance, do a new data collection. And you might notice that some of this is done often in robustness tests and appendices because referees asked for it, etc. So they're not necessarily things that happen outside of the original article, but often they do so. Generalizability is when we actually take the scientific knowledge that we gain from this and we try to apply it with different data, different methods, different contexts. And again, the boundary here is not always clear. What does different methods mean? Does it mean I'm going to add another covariate? Does it mean I'm going to switch from logit to probit? Or does it mean that I'm literally going to use a radically different method applied to very different data, etc.? That's the scientific discourse. But to be able to talk about these, we need to see what is actually different and be able to measure that. That we can only do if we start far off on the left of the spectrum at the computational reproducibility part. So there has been progress over the years, and what we see today is a world where there are replication archives and data availability policies at various journals, where there is shared open source software, and whether or not part of that software is commercial, for instance, data, or whether all of it is open source, such as in R, is to some extent irrelevant, and I'll point at some of the commonalities, for instance, economics, but in other social sciences as well, what shared software actually means. And that's an important part of this. We have, compared to what we might have had 20, 25 years ago, much better public use as well as shared confidential data. And that is an enabler of a common conversation among scientists, right? It used to be, and it still often is, that if you have access to some element of confidential data, you may be the only one who can access that data. And so reproducibility is hard, but replicability or generalizability isn't necessarily. But we also have nowadays networks and methods and agreements that allow us to share confidential data in an ethical way among hundreds or even thousands of researchers. And the logos you see on the screen are from networks of such research data access centers, right? And we have better ways of accessing preprints and grade literature. That's worth a talk on its own that I'm not going to get into too much today. So the issues that have come up and that the current landscape is a response to has been that even at the very basic level of computational reproducibility has been weak. And so the bubbles that you see on the screen are what evidence we have that the results in empirical articles from a select number of studies that I picked for this are reproducible, so that when somebody else takes up that same analysis, they can actually come up with the same results. And the reason that there is multiple bubbles at the very end is because you can discuss what goes into the denominator. Do you want to count everything or only those where the data can be made available? Do you count minimal errors that are easily fixable by anybody with knowledge of the software, or do you want push button reproducibility? All those things determine what number you're looking at, right? And so in our own experiments, we found, for instance, for one particular journal, that 40% of articles used restricted access data. So their replication archive did not have a copy of that. I'll speak at length about that later on in the talk as well. Of the remaining ones, we could sort of cut these into pieces about all the data was available and mostly or completely reproduced what was there. That's about 25% of all papers. But another good chunk of those either were only partially reproducible, and partial reproducibility means either that the code failed or that a part of the analysis required confidential data, and 10% just failed to yield any useful results. Okay? So what are the causes of that is something that we looked into, and how can you avoid being in a situation where you're left with 25% that actually reproduce cleanly and simply. You could argue that the glass is half full. You can argue that the glass is half empty. It is better than nothing. It is certainly better than when we started out 20 years ago. And the elements that I mentioned earlier, for instance, about shared open source components, data packages, R packages, R itself, etc., have contributed to the fact that we're not talking about an empty glass. We're talking about something that's at least half full, right? So progress has been there, but we'd really like to get it all the way up. It should be straightforward to be able to say, yes, I'm totally assured that what is going on there is there. So what are some of the reasons that we've identified as being a part of this? One of them is that if you let researchers take care of handling where the replication package is, they won't, or they won't do it very well. And so the failure to curate the packages was one of the instigators why 20 years ago journals started to put together code availability, data availability policies that said, if you're going to publish with us, we're also going to take custody of your replication package. Please drop it here and we'll ensure that it exists. Now, it doesn't ensure that it works. It only ensures that it exists. And we certainly have run into packages that were sitting on journal websites where the content was not usable or what had been corrupt for a couple of years and nobody noticed. The other obvious culprit is poor coding practices. We are social scientists. We are not computer programmers, and even computer programmers make bugs, and you've certainly faced buggy software and all those kinds of things. But there are a few things that should be relatively straightforward to address, and I'll get into that in my practical notes. One of them is to avoid as much as possible manual manipulation of results. If it takes 20 pages of manual instructions to replicate your paper, you're doing something wrong if much of that means that you're interactively coding or running code or some of these things. And the other one is lack of robustness. You might have run this at some point in time and fixed the bug, but the code that you saved is not the code that you actually ran. And so bugs in the code are clearly a thing. And in the pre-publication replication that I'll talk about in an instant, these account for the largest part of return to sender reports where we have the authors fix these things, right? The other one is poor citation practices. If you're not providing me with a copy of the data, and even if you are providing me with a copy of data, I'd still like to know where it originally came from, when you got it, because sometimes data changes. Even at big statistical offices, at the US government or the Canadian government or any one of these, some of the data series are revised. And so it matters when you pull down the data, we'd like to know that, we'd like to have a copy if possible, etc. Right? And this is just talking about the public use data. Sometimes the description is ambiguous. What does it mean that you use the current population survey? Which version? The one at NVR, the one at IPAMS, the one, there are multiple versions of them, and we'd like to know where you got it from, and then subsequently how you possibly cleaned it and subset it. Okay, so creating reliable archives means that you need to have good descriptions, you need to have a permanent location, you need to be able to quickly assess the quality, and all those things are not easy to implement if a researcher is doing that, or even when many of the journals have been doing it. Now, there has been progress in the sciences. One of the very important innovations has been to think more fundamentally about these things, and one of the things you should have heard are the fair data principles. What are they? They mean that data needs to be findable, accessible, interoperable, and reusable. Okay, and most of the replication packages that you will still find on journal websites don't actually satisfy that very easily. They may be barely findable because you know the article, but not necessarily the package itself. They are kind of accessible. You have to download them, unpack them, and then you realize there's nothing really of use there. That doesn't really count as accessible, but well, you can do so. Interoperable and reusable mean that they're documented enough so that somebody else can make sense of that, not just physically run it. That's the interoperable part, but reusable is you understand what these data are about and could think, well, I could actually use this data for something else that isn't actually the original intent. So reproducibility challenges are in the first three letters of this, namely the findable, accessible, interoperable. The reusable is to actually increase the value of the data that's out there. And the data citation principles came afterwards are an attribute of that. They are supposed to assist in making the findable and accessible part become operable by giving increased credit to data producers, whether those are statistical agencies, government agencies, or individual researchers, and to be able to clearly identify what the data are. And I'll spend quite a bit of time today talking about that. Okay, so given these issues, what are the possible solutions? What should we do? Well, the WEAI is a broad stream within the social sciences that I'm aware of, but in some of the biological and physical sciences just as much. And part of it has been the realization that without greater enforcement and possibly a greater role for the journals to do that enforcement, we're not going to make much progress. So the idea of stronger enforcement of existing or the implementation of new data and what I call code availability policies has been relatively prevalent. So the American Journal of Political Science, the American Statistical Association, Science, and ultimately also the AEA and a variety of other journals have gone on to sort of say, yeah, we have a policy, now let's put somebody in charge of enforcing it. Right? And so that is the task that I was appointed to at the AEA. What it means is that the AEA, the largest association of economists, not just in the US, we have an international membership, but we have 8 journals. And over the past year, all of those 8 journals have come to be subject to my purview to check prior to publication the replication packages that accompany these articles, right? And so what do we do? And I'll be walking through these things one at a time, is that key and foremost, and the largest part of our activity is that we preemptively check code archives. And I'm going to emphasize code archives because sometimes we don't get the data, but if they include data, we're going to do some of that as well. And it doesn't just mean in our case that we just say, yeah, we got them, we had a look at them, they seem fine. We're actually going to conduct reproducibility checks. I'll go into a bit what that actually means. If we can't conduct that reproducibility check, then we actually rely in an increasing number of cases on third parties, groups that have access to the data, and potentially the code, and that can conduct the reproducibility checks for us in a manner that allows us to be satisfied and to convey that to the ultimate reader. We're also focusing on better archives. One of the things that was important to me when I took the position was to make greater transparency of the code and data archives a key aspect. This directly addresses the findability and accessibility part of the FAIR standards by making, rather than having a blob of data tucked together into a zip file sitting on a website that can't really be assessed, into something much more structured. And I'm not reinventing the wheel here. This is something that trusted repositories have done for decades. And so we ended up leveraging that knowledge for what we do here. And to get at the trustworthiness of some of the things that we're talking about, but a provenance tracking, where does the code and the data come from? Ideally, we want to build out that if it comes from a place where it is properly archived, then please leave it there and just point us to that direction if we can access it. If it is in a place where it might change or might disappear, then we do want a copy of it. But to gradually move away from providing all the data and destroying at the same time the provenance information, we're trying to get at both of these. And so last year in July, we announced a new data and code availability policy. And some of the key aspects are highlighted here on the screen. Are the innovations that we implemented were that you needed to clearly and precisely document access to the data and to the code in a way that is obvious to readers and ideally non-exclusive to the authors. We do so prior to acceptance. That gives us a lever that allows us to say, look, you don't get what complies with our policies, you are not going to get your article accepted. Now, there's a limit to that. We have accepted that basically it's scientific. Benefit has been ascertained by the referees. There are the occasional attempts to look at reproducibility prior to even the conditional acceptance condition, but most of the time we work on the interface between a conditional acceptance and the final acceptance. One of the things that we focus on is that if you cannot provide us with the data, you are not exempt from the policy. We test whether or not you can provide enough information about access to the data. Is that information precise enough? Is it accurate? And we will test that, and I'll get to that in a moment. So what do we actually do when we talk about pre-publication verification? Once a paper gets a conditional acceptance, we get the paper and the replication package, and we verify what you see on the screen here. We verify data citations, that's the provenance tracking. We check the quality of the README. Is there enough information in the README to allow somebody who's not intimately familiar with the entire history of the code and the data that was written here to actually go through and reproduce the results? We check the quality of the code. Can we identify where table 1 is being generated? And we verify that the reproducibility of the code is at least in principle assured. Or do we identify that people tell us what kind of packages were used and things like that? And you'll notice that none of that actually requires us to run any code at all. We just need a copy of the code. And then we actually go about to run the code itself to see if, given all the data that we have access to, it can actually reproduce the figures and the tables in the paper. We then also assess that the quality of the metadata in the repository is high enough, and we encourage people to actually improve it. And I'll go into some detail on that when I show you an example of that. We are firmly to the left of this platform. So we only check that the code and the data reproduce the figures in the tables. If you have a reliably programmed bug in the data that does some nonsensical stuff and reliably reproduces the same wrong number, we will certify that. We are not going to second guess these papers. That ultimately is the role of a scientific discussion. It's ultimately a role of the referees. The referees didn't get access to this. That's our long-term goal, is to make it so that they can actually get access to that during the refereeing process, but we're nowhere close to that yet. But at a minimum, this is something that the community can do afterwards because all the code and the data is available. Right? So we assure that what you see is what you get, that this is consistent with what's in the paper, and then it's up to others to later discuss whether or not it was the right thing to do or if there is some fault in it. I should note that given the platforms that we use, that post-publication revisions of repositories to either align them with better practices are possible, and we are still going to have to define how that actually enters into the standard old publication process, but the technical platform is there to do so. All of the checks that we do, the list of things that I just mentioned, are public on web pages that we maintain together with some other data editors in the economics community, and I'll provide pointers to that at the end of the talk. So if you want to check preemptively before submitting to us what it is that you should be doing, everything we do is public and on this web page. Right? Who does this? Well, mostly this is delegated to undergraduate students. not all of whom are in economics. We've got engineers, we've got statisticians, we've got sociologists, and we have economists. Here's the very long list of folks who have transitioned through our lab. I couldn't do this without them, and they are perfectly capable of doing that, of following a clear README, even if it is for a complicated econometric paper. As long as the README is clear, as long as the code is functional, doing that is relatively straightforward. It is what other RAs have done to write the paper, who have certainly contributed to writing the paper, so why shouldn't other RAs do that? It is what allows us to actually do this on a relatively large scale, okay? So you are never going to see any of these names specifically associated with a paper, but all of these folks are, the ones in blue are currently active on my team, the ones in black are prior members who have contributed to that and who have gone on and graduated and all these other things. And the goal is obviously to reproduce all of the papers and to move that topic up. We provide specific guidance on the website, so if you're actually submitting to the AEA, we provide very detailed. We're in the process of revising that and making it even clearer about what it is that you need to do. So all of this is out there and up there. The actual report that you will receive as an author once you submit the paper to us, all of the elements that you are going to see in that report, the template is out there. You want to pre-fill it for us? Please be my guest. That'll make our life so much easier. So in the past year, we've done about, if I counted right last night, 636 assessments, right? So most articles go through at least a second time, so and sometimes more. We have so far 233 manuscripts accepted, so they're either have been published or are scheduled to be published, and we're done with that. And there's obviously some others that are always being processed at this point. Okay, that's a lot, but we can't do all of them because we have to occasionally rely on other parties when we don't have the computational resources, the software resources, etc., to do these kinds of things. I'll name two of them, Cascade in France and R² at Cornell. And there are a few others at various other universities that we have not yet reached out to. Various contributors have also provided us with reports when we can't access the data. We have reached out to folks who either are arm's length removed from the authors or are completely unknown to the authors, but happen to have access to the same confidential data. They are an important part of this. It doesn't happen all that often, but it does happen often enough that we can say by now that there's a significant chance that even if the data is confidential, we are able to check for reproducibility. Okay. Better archives means that we, in our case, went to OpenICPSR, but there are a number of trusted repositories of this kind out there. You've probably heard of some of them, the Harvard Dataverse, Zenodo, there's a variety of others. And this is important because it gets us much more metadata into these deposits. So what you're looking at is what is called metadata, information about the data that has been deposited. And you can see elements such as the time period that is covered by the data, the geographic coverage, subject terms, a precise definition of the universe. And not all of these apply to all data. If you're running a lab experiment, then geographic coverage might not be quite as clear about that. The collection dates, on the other hand, might very well be. And so there's a lot of information there that will allow people to describe the data and ultimately to show it to others on the website. And so this is an actual deposit that we have received in the past year. It is for an article that's associated, for data that's associated with an article in the AEA. And in contrast to what you might have seen in the past about zip archives, now you can actually see all of the data sets, all of the code. You can download individual elements to have a look at them first before you download the whole thing, which if the archive is really small, doesn't really matter. But we also have a few archives that count in the gigabytes or dozens of gigabytes. And so that might be something to think about, in particular if you're sitting on a home network connection and not at a university connection. The important part is that the data itself is citable. It is linked to the article that itself is citable as well. And this information is not only there in a human readable form, but it is also there in a machine codable form. Whether it's readable by a human is a different question, but all the information is there. And what that means is that you are able to find this thanks to that metadata. So this is what you would get if you searched for something related to this on Google Dataset Search, and you will see the same kind of information available there. The data is now findable independent of the article, but it links back to the article. So it's another path to finding the article itself. Okay. I mentioned earlier that commonality of software is an important component. Once we actually have archives like this, we can also parse them and figure out what's in them. And so one of the things that we have looked at is how much diversity there is in software. There is not a lot. Nearly 73% of all archives have Stata, at least as part of the processing stream. And what's left is MATLAB. And then on the graph, you can see at the very bottom a gaggle of lines. All of those are various other things with no obvious trend towards more modern languages like R or open source languages like R or Python. Economists just like Stata and MATLAB a lot. And you can think, if you yourself have recently gone through your university studies, your choice of software is often driven by what your thesis advisors have, so there's a lot of persistence in that. If you look at other domains, then you will find other distributions. You might find SPSS as a frequently used software, or something other again. Of note, compared to, for instance, biology or things like that, that most of the software here, Stata, MATLAB, is commercial. But both have strong components, Stata much more so than MATLAB, of open source add-on packages that are critical, but that are actually openly viewable by others that have an active community around it. Other disciplines have a lot more source code that is custom compiled for this kind of thing. That's less of a thing in economics. And so one of the things is that because we only have these two very dominant software packages, it's relatively easy to understand what somebody else is doing because you're speaking the same language, even if you have to pay a couple $100 to acquire that language. And so provenance tracking is where we look at data citations. And just because that's most of the time absent, this is what a data citation looks like. It's very much like a standard citation for an article. It just has some other more technical aspects to it. So I'm going to use this as the launching point for some practical tips. But before we do that, I wanted to ask you to fill out a survey that we occasionally do to poll our participants. Like I said, I'm speaking from the perspective of an economist for an economics journal, but many of the lessons that we are going to learn here are more generic. So I think Alex is going to pop into the chat box a link to a Google survey where we ask a few things about your experience with some of this. Have you already tried to replicate some of the studies? What is your domain? Have you done any of these things in the past? And so we'd like to learn a bit about you. So while you answer that, let me go into some of the more practical tips based on the nearly 700 assessments that we've done.
There's a question in the Q&A.
Okay.
You could leave it till later, or if you wanted to answer it now, there might be some time. From Wade Martin. He's wondering if you expect this effort to extend beyond AEA journals and if your group will support non-AEA efforts.
So that's two questions. One of them I have an answer to at the very end of the talk. The short answer is yes, absolutely. What we're doing is not just at the AEA, and we're on the verge of making a joint statement by various other data editors. Whether my group can handle at this point in time others than AEA journals, the answer to that is no. We're behind on our schedule for the AEA itself. And figuring out where those bottlenecks are is of concern, but we are preparing some guidelines on if other journals want to do this, if other groups want to support other journals, here's how we can do that. it's not out of scope that somewhere in the near future we would have enough capacity and enough streamlining of the process to actually support other journals. I've had the query before, and it is on my wish list of things to do. But in the short term, we are at capacity with what the AEA is doing. Okay, so let me start by asking a somewhat flippant question. Would you buy a car from this guy? Well, we don't buy cars every day, but when we do, we have some questions about the whole process, right? Do we really want to buy a car from the guy on the corner, or do we want to buy it from a dealer or a reputable dealer? We're talking about the provenance of both how the car got to where it is and where it came from. What do we know about the salespeople? Are they trustworthy? Where does the car come from? And what do we know about the car? You can get a Carfax report that tells us the provenance of the car, okay? The analogy is, would you use this data, right? And seen as such, that's a pretty nonsensical question. I'm just showing you some hexadecimal coding or something like that. But as you sort of expand that, the question, of course, is, would you use this data? Right? And this, we know where it comes from because it hit the media for a while, and you probably wouldn't, because somebody messed up the way that they presented the data. And does that yield some concern about where the data actually came from and how it was processed, etc.? So does the data provider have a good record? Where did the data come from, and what do we know about the data? That's what we call metadata. And metadata can take many aspects, okay? So let me flip that same hexadecimal data around and call it stock market. It's a spreadsheet. Well, I kind of have some idea what it's supposed to mean, and maybe now I can actually interpret those hex codes and turn them into a series of numbers. But do I still think that I know everything that's needed about the data to call it trustworthy? I don't think so. Okay, so I'm going to call it the S&P 500. Now I think I know what is going on here, and maybe I have some idea that this seems plausible, but it's still not the whole story, because your claim that this is the S&P 500 needs to be substantiated, right? Well, if I tell you I downloaded it from Fred, that gives me some guidance because I know what Fred is. But I don't know if other people know what Fred is unless you expand that a bit and make it a bit clearer again. Is Fred a reputable package, or is Fred just the car salesman from the original picture? Right? So where you got the data from needs to be clear as well. So let me add a data citation. Okay, now we have a lot more information about who created the data, where I got it from, and I can click on that URL and dig down into that. Right? And so now I know that Fred has something to do with the Federal Reserve Bank of St. Louis. That is probably a reputable place. It turns out it's a very reputable place. And I have a URL where I can check out some of these things. I even know when you download it. Right? But you're not going to be providing me with that data if you actually read the fine print, because as it turns out, even though it's on the website where I can download it and you can download it, I can't give it to you because it's copyrighted by Standard & Poor's. Okay, so these are data availability statements that one would expect to see. It describes the data file, where to get it, how to get it, which is in the URL, and any conditions of obtaining it. In this case, because it's copyright, I can't give it to you, but you can get it yourself. Okay, and the data citation itself. So that satisfies the idea that the data and code, in this case the data, is clearly and precisely documented, and in particular is non-exclusive to the authors. Okay, so every manuscript that we go through is checked. What data sets are used? Are they cited? And while we prefer them to be cited in the article, sometimes if a data set is only used in the online appendix, it might only be cited in the online appendix. And as a stopgap, we're fine with you citing it, but properly citing it with a reference section and all in a README. Right? Is there any additional information we need on the access? Does the URL lead to the exact data, or did you just tell me, oh, go to Fred or go to St. Louis and find it? We want the exact location because sometimes it's not clear what that is, right? And you might send us to a page and there's 50 data sets on there and they're all similarly named. We'd like to actually know which one it is. And so providing both a proper citation that somehow stylistically fits within the article and the exact information on how to download it is important. And not every URL provides a one-click download. Sometimes you have to enter information manually into a query website or things like that. So precise and clear documentation needs to identify, if you can't just click on a link and download it, what do you need to do to get to the point where you can download something? And you think that that's a rare event. Well, one of the biggest data providers in economics is IPAMS, and IPAMS, you cannot download the data set. You have to go through a query system. One of the more reputable ones in macroeconomics is the OECD. And up until recently, I think they've just changed that, you had to go through a query system and then download the resulting data. So this is not a rare event. Does it lead to an application procedure? Do you need to apply for the data? What kind of information do you need to provide? Do you need to provide a justification? Is it all very complicated? Is there some additional information I need to do, or is it something that I need to be? Do I need to be a citizen of the country? Do I need to be a resident? Do I need to be a university scholar? Or as a journalist, can I get access to the data as well? So these are important parts that are not necessarily embedded within a citation. Even if you ended up giving us a citation, there's additional information that may be needed. When we talk about reproducibility, we actually check if the access to the data is reproducible. So we actually, my RAs, go through and click on these things and see, do they actually get all the way to the data? Okay, and in particular, is there any license or data use information? And you'd be surprised how often we've learned that either the author said, I can't give you the data, and yes, they can, or they gave us the data and they probably should not have. And so these are two things that we look into, and we're not perfect. We don't capture all of them, but we try and protect our authors from their own missteps, and we try and entice them to actually provide the data when some of these things are possible. And we talk to data providers. So for instance, the academics who run the Economic Policy Uncertainty website used to have a copyright on it, and we had some authors say, can't give you the data, it has a copyright on it. Thank you for reading and understanding what copyright means. Let me contact the authors, the providers of this data. And as it turns out, they then changed their policy and changed it to a proper license that actually does allow for reuse and redistribution. And so now you can provide us with the data because we're giving the data to somebody else. And so as a researcher, whether you are an undergraduate or a seasoned tenure track professor or a tenured professor, you need to know whether you have the rights to use the data, right? You browse the website. That means at least you could look at it. That doesn't necessarily mean that you can use the data. If you purchase the data, you sign a data use agreement. That's a right to use the data. You created the data in a lab experiment. That probably qualifies as you have the rights to use the data, but careful, because if you ran a survey, you still needed consent from the survey respondents to use the data. So just because you collected it doesn't automatically give you the rights to use that. And if you run surveys, you know that. But the same is true for data you collect from somebody else, right? That is different from the right to distribute the data. Just because you had the right to use the data does not mean that you have the right to distribute the data. Far from it in many cases. If you created the data, then you decide. If you ran a lab experiment, a simulation, it's up to you to decide, right? But if you got it from somewhere else, read the terms of use, the data use agreement, the click-through agreement, whatever it was that allowed you to use the data in the first term, because it might actually say that you can. I showed you the economic policy uncertainty. The creators of that changed their policy to be clear about that. I also queried a second academic provider, who I'm not going to name, who said, no, I'm not going to allow people to redistribute my data. This has worked fine for 20 years. I'm not changing that right now. Anybody can get the data from my website. Let them come here. And so one gave us a copy of the data. The other copy we excised from the data replication archive. And to go back to my S&P 500 example, that is very clear on the page where people would get this, except you have to scroll all the way down where it says permission to reproduce the S&P 500 can be obtained from Standard & Poor's, not from Fred, right? So while they can display it and you can use it, permission to redistribute is not automatic there. It's copyright, okay? And they also provide you with information there. Well, restricted access data is the ultimate piece, because here it's very clear you're not allowed to redistribute the data. You walk into a locked room and access the data, right? If it's not on your laptop, surely you cannot redistribute it, and that's probably true. But it's also true when you have data that you can download onto your laptop under some data use agreement. And often, if it's from private companies, you're pretty well aware of that, but there are quite a number of other sites where that is true as well. The other part, of course, that we get is that, well, if I can't download the data, I can't cite it, right? Well, that's wrong. And we walk you through some of those examples. Some of the better ones are actually restricted access environments that actually help you and construct the data citation for you. In fact, the German Research Data Center actually has DOIs assigned to it. The French one will soon too. That is something that is totally awesome. You can click through to it. You get a unique identifier for the data set, even if you can't download it, but it tells you everything on how to access the data set. It gives you descriptions. It gives you documentation. If you go to the US research data center, restricted access data centers like that, you get more summary information, right? But we can still construct the data citation from all that, right? So ICPSR and generic citation guidance tells you that a citation should include the following elements: author, title, distributor, date, version, and persistent identifier. And now, if we go to our S&P 500 example, that's pretty straightforward, right? The author is the Standard & Poor's, right? The distributor is Fred. So those are two different things in this case. We have a title, it's called the S&P 500. I have a persistent identifier where I can get it, not perfect because this changes over time. There's a rolling 10-year window, but I have at least a date that I downloaded it, right? And my data availability statement should say that if I go back and download it tomorrow, I'll have a bit less data historically, and I'll have some newer data out front, right? And so for the German restricted access data, literally you cannot download this data. This looks almost identical. It's actually even better because I do have a persistent identifier. That is the DOI that they gave me, right? And that also qualifies as the version because they lock that in and they actually are explicit about there being previous versions, right? So for the Census Bureau example, could I do something similar even though they didn't build and give me a data citation and don't have DOIs? Yes, absolutely, right? I know the distributor. You have to walk into a room, that's the distributor, and they give it to me, they can give it to others. It has a name, it has an author, a data creator, it has an access date that is the one that you accessed it, and it has some sort of version identifier that might not be perfect, but is at least approximating what that might be, right? So any data set, whether or not it was a simple copy of an internal data, administrative data set or something else, can be cited by just following those simple guidelines, right? Data availability statements go a bit beyond that. For FRED data, for instance, a URL is sufficient. How do you get it? Click on the URL. IPAMS data, you need to register and then provide details about the query system. The IAB writes it for you, what you should put in the data availability statement. You have to go into an on-site and there's an access procedure and an application procedure and all those kinds of things, right? So we check these things and we regularly get examples where, okay, somebody used, say, the World Values Survey. Here's the data citation. Wasn't in the paper. We added to the request to the author to do that. And then when we click on it and go through the exercise of actually trying to download the data, well, there is that part of the data use agreement that says data files are not redistributed, and you gave them to us. So that is a red flag. In their case, it's actually written in red that says you will probably need to remove that data. And so we check for these things in the manuscript, in the README or the appendix for all of these elements, okay? So takeaway on the data part, citations, access, and rights. You need to be aware of your rights and the restrictions of those rights. Any data can be cited, even if you can't download it. It's a very simple 5-point checklist to construct a data citation. Any data that you accessed can have that access be described. But caution, just because you access it in a particular way doesn't mean that others can go through the same path. So for instance, US taxation data. If you are an employee of the Treasury Department, you have access to that data as part of your job. So you don't need to do anything special. But that doesn't mean that your access to the data is exclusive, because there are other government entities and other research institutions that can access the data. So please do describe what the data is. The way you access the data, please describe it as that way, but don't assume that that's the only way to access the data unless you really know that that's the case, right? And distinguish between sharing data, accessing data, and publishing data. In some cases, you can give us as the data replicators the data and we don't publish it. So that's not the same scenario, okay? So that's theme one. That's what most researchers get not quite right. And it's important for the credibility of the data is to have a consistent, universal way to track the provenance of the data that you are providing, that you use for the analysis of the data, to allow others to assess, do we think it's credible, do we think it's generalizable, do we think it's replicable, etc. Okay. And I presume there will be some questions at the end, but since I can't see the QA at this point, I'm going to go on with some guidance on coding for reproducibility. Okay. Here's the other big thing that we constantly run into. Please follow robust coding exercises. Right? So robust means that they reliably reproduce results, ideally in an automated way, and that you don't build up the results over time, modifying things along the way in ways that are not reproducible. Ideally, if it's not too onerous, rerun the entire code at the end. And if you think that that's a lot of work, then you probably didn't do the coding right, because we're going to go through the same amount of work. Right? And the key thing here is the mindset. Assume nothing, with some caveats, of course, right? Put yourself into the mindset, I have a fresh laptop, a new software install, and everything I installed previously is not there. And now all I'm going to have is my own replication package. We'll take it one step further. You might have an RA, a buddy, or something like that. Assume that they will run the analysis. You're allowed, you're going off on vacation. You want to go onto that island on your own and do nothing while they run through the code, right? So that RA, she knows Stata or MATLAB, but she doesn't know your directory setup. She doesn't know that secret command line foo or the secret way to look through the code and know that that number is cell number A1 in the results table. All that needs to be coded in, right? A master script is preferred. There shouldn't be any manual manipulation. All the packages that you rely on, maybe that you installed 5 years ago, don't assume that everybody else has them, because they don't. And so there's ways to automate some of this. It's pretty straightforward, and we've got guidance on our websites. So some extreme examples of what we've actually seen. I've paraphrased here, but this is literally what we've seen, right? MATLAB, a real example, 10 figures, 4 panels in each. So 40 graphs, each of them constructed using the comments on the right. For figure 5A, comment line 52, uncomment line 151, run the code, and then manually copy the figure into your document. Undo those changes partially, then do something else, and again. Do that 40 times, and you have a pretty onerous replication that, in essence, is just the result of poor programming practices, because you could have parameterized all of that. A database estimation with lots of manual copying things into various places is also the result of doing things over time, not redoing them once again just prior to publication, copying programs around manually, converting output manually, copying the result into something else, etc. These are bad practices, but they're certainly solvable in a relatively straightforward manner. When we complain about them, typically 2 weeks later, we have them solved. So why not solve them right away, right? And so the ideal setup ideally has 2 programs, one to set up the environment and one to then actually run through the code. Now you have something that is both useful to a replication check, a reproducibility check actually, and one that is also useful for those who'd like to expand on your work to replicate your results or to generalize your results, right? One's to set it up, and then you are in the environment that allows you to play around with it, to modify the parameters, to test the robustness of these things, etc. This kind of setup can be done in every single programming language that you can think of. MATLAB, Stata, R, Python, Fortran, C, whatever you can think of, you can do it in that. Subroutines to automate loops and things like that exist in every language. They might not be called subroutines. They might be called do files. They might be called macros. They might be called something else. But they exist in every language. And they are an enormous time saver if you think of the fact that you're supposed to run this again just before submission, right? And key, and we see this really very often, is the ability to output figures and tables into a proper file on disk that you can then reference uniquely, rather than saying, oh, copy it out of the log files or hand copy these numbers that are scattered throughout the text. Again, these facilities are present at the basic level without any add-on packages in almost every language, and if not, there's an add-on package that you, of course, you included in the setup program, right? So how to prepare a replication package that actually ticks all those boxes? Write the README, construct the full package of all programs, zip it up. First, do it yourself, throw it into different location on your directory. Go to a different computer you might have sitting around or something like that and try and run it from there. Then ask somebody else to run the program and download the package that you provide them with, follow the instructions in the README without talking to you ever during the whole process, and have them compare the results to the paper. If you're nice to them, you will compare the results to the paper, because that's really onerous sometimes as well when you have 40 figures to compare. That's actually the protocol that we ask third parties to go through. And it's the protocol we ourselves go through, because my RAs never talk to the authors. Right? That's a very robust way to construct a reproducible package that is certain to satisfy any and all requirements that we can throw at it. Right? But I just said you can't give me all the data, right? So what do we do then? Well, then we have those 40% that use restricted access data, and there's a variety of ways we can go about that. I mentioned Cascade earlier. They actually have an omnibus access to the French confidential data. And that's not universal, but it is something that we can definitely work with. And there are similar activities that we have explored with the German data, with the US data, with Portuguese data, with a variety of other data. In some cases, we ourselves have access. We got a replication package that said, I use Brazilian data, can't give it to you, you can't run this first part. Well, it turns out I work with Brazilian data, and my RA was not able to replicate the analysis because there were programs missing. And so we figured those things out by trying to run it against our copy of the confidential data, which was entirely within scope of our terms of use, and we ask other people to do the same thing. Right? And so we've done this with French, Brazilian, US confidential admin data. We've done this with purchased commercial data. We've done this with proprietary data. We've signed data use agreements with the original data providers to obtain access to the data and then run that. We've done it both on our own computers or by accessing stuff remotely. It doesn't happen in every case, but there definitely is a way for us to do that. And you cannot assume that we don't have the access to that. And last but not least, and this goes in part to the question that, that Wade had earlier, the role for journals in this, all of what I'm putting forward here is not unique to the AEA. The thing that is unique to the AEA is that we do this pre-publication reproducibility check at that level of intensity for every paper that we get. But the idea of putting together a robust replication package that you would not be ashamed to put out there on the web because anybody can take it and can run with it, etc., is not specific to the AEA. And in fact, any standards that we would impose on it should really be transportable across all the journals. And so that's why we have what we call the Social Science Data Editor Guild, because there's some Europeans in that, and so there's some old-fashioned things that we like to do there. But we have a website, and anything that is common to the journals we put on that website, not an AEA website. The basic structure of a README that guides you through it, the basic ideas about data citation, you will find them on this website. And we are actively working together with data editors in an expanding, hopefully expanding group with other journals to discuss some of our more thornier problems. We get regular queries on our mailing list. I have this one thing, does anybody have experience with that or any solution to that, etc. So we coordinate because this has to be a general purpose thing. It has to be about, at least in economics, I would hope for more broadly in the social sciences, to be a common way of addressing these things, not a journal-specific way that you then have to undo and redo differently if you're going to submit to a different journal. I'm going to skip that. So with that, thank you very much. The slides will be posted at the DOI that you're not going to remember, but we'll post them on the BITS website. And in particular, there's a couple of resources where you can find almost everything that I said in this talk in written form. And I'll stop there and open up the floor to questions.
Great, thanks, Lars. There's actually a couple questions in the Q&A. I can either relay those to you or you can read them. And then after you answer those, I can just open up the floor for other guests.
Yes, so let me get out of sharing because then I can actually see the Q&A as well. Okay, so let me take the two questions in the Q&A that I see. So Diego has a questions on how to accommodate research on confidential micro-level data sets from the IRS or census. I hope that you saw from this that there is definitely a way to doing that. We are currently preparing, as part of our improved guidance after a year of doing this, some concrete examples with IRS data sets on how to cite them, how to describe access to them, etc. For the Census Bureau, I gave you an example on how to cite the Census Bureau data sets. We actually have linked some really good examples on how to do data availability statements for Census Bureau data sets. And all of that information is on our website. So to describe that and to cite it is relatively straightforward. How to conduct reproducibility checks is a bit more complicated, but we have an active working group with the Census Bureau, kind of waiting for the current pandemic, which has had a very good response from the Census Bureau, but it's put all hands on deck out there, as well as the fact that they're currently running the 2020 census has made resources a bit scarce. But we do have a project to actually go in and verify research projects that used census data live during the reproducibility check or possibly after publication, but still to go in. And I have successfully requested reproducibility of IRS data sets from people who have legitimate access to IRS data sets, and I've gotten back some really useful results on that. So you can cite them, you can describe the access to them, and it can be part of a reproducible workflow. In fact, in many cases, it has to be reproducible before it even exits the floor, because if you can't demonstrate to the Census Disclosure Review Board that the numbers that you're trying to get them to release actually come from legitimately run regressions, you have a problem, and they won't let it out the door. Okay, so Sean has a question. Okay, so repository-specific problems, these are going to be different. So Sean mentions that he had trouble maintaining the directory structure. That is actually one of the reasons we picked OpenICPSR, because on OpenICPSR, you can maintain that directory structure. The trivial way to maintain a directory structure is to upload a zip file, and there's a tendency to do that, but on OpenICPSR, that's not needed. So you don't have to be a submitter to an AEA journal to use OpenICPSR. You can just upload that as well. Dataverse, I think, is working on the idea of having a more complex, rather than their current flat data structure. That is a feature of Dataverse. Zenodo allows you to upload a zip file, but will then display the contents of the zip file, so thus also maintaining both transparency and the maintenance of that directory structure. So that we regularly go back and ask researchers to use the import from zip structure that unpacks the zip file in OpenICPSR and maintains the directory structure. So very good question, but that is part of that. So Floor asked if we do this to AEA articles now or back in time. We're only doing this going forward, so we're not revising articles. That is where we started. We literally took all of the articles in AEJ applied, and with a much smaller team of undergraduate RAs, we tackled attempting to reproduce them and classifying them. That's actually where the numbers, the colorful bubbles came from that I pointed at earlier. But that doesn't change the actual repository. Now, there is the possibility that if a researcher becomes aware that there is a bug in their deposit at the AEA, that they'll knock on our door and say, I'd like to fix that, and we're definitely open to that. There will be shortly a policy about when we actually link to the newer one, but at a minimum, on OpenICPSR, there can be a version 2, a version 10, a version 25, if that's what it takes to get it to run. One of those will be linked to the article because it's the version of record as you published it originally, but there is a way to actually get at the fixed versions of that. So we don't do this retroactively. That remains a research project. It's a very engaging exercise to do with undergraduates because you can show them that things can go wrong and how they go wrong. Hopefully down the road, that exercise will be futile on the stuff that we do, but we are also not perfect. So I don't expect that people who want to do that will be completely out of a job with the AEA. But we're definitely trying to reduce the number of things that go wrong when you do that down the road. Do we have, okay. Flora adds on an additional question about will that be noted in journals? That's a tricky question. Corrections to journals are a rare thing in almost all of the journals. It's outside of my scope to figure out whether or not to do that with the journals. Certainly you can, certainly we have in the past at the AEA corrected supplements, but the article itself is immutable. There are very few comments about something is wrong with the article or something like that historically. That is a general phenomenon as far as I can tell in economics. For a variety of reasons, that is assumed to just be solved in the downstream literature. And that is generically probably not wrong, but whether that's the ideal way of going forward is an active discussion.
And just a reminder to all the attendees, if you would like to ask a question by just speaking, you can also, I believe you can unmute yourself. So we also welcome comments and questions that way.
Yes, please. Don't be shy. I'm almost certain I did not answer all the questions.
Lars, this is Wade Martin again. How much time does all of this take? I mean, are you looking at, say, the number of articles submitted that you're reviewing and replicating? Is this a significant effort, endeavor for an organization to undertake? Are you able to handle, do you only look at the ones that have been accepted for publication to then replicate?
So the way it's currently handled at the AEA is that I only see, it's not entirely true, I'll put a caveat in there. We see the articles definitely when they're conditionally accepted. So they pass peer review, the editor has reviewed the comments, it's good to go forward based on the content of the article, and now we start checking these things. We are primarily focusing on the computational reproducibility, so we do not spend a lot of time focusing on data documentation. We don't ask every researcher for every data set to have a full code book and things like that. That would be useful, but there's a lot of shared knowledge about this, and so we're punting a bit on that. We focus only on the computational reproducibility. In theory, if our queue is empty, most of the articles can be done in about a week's RA time. But historically, we haven't had enough RAs because it takes time to train them, and then things like finals and midterms and things like that get into the way, because I do this entirely with undergraduates. And so we do have a significant delay right now relative to our goal of solving this within 2 or 3 weeks of receiving the manuscript. I currently have about 18 RAs working on this. I have 8 journals who send me a large number of papers per week. It fluctuates a bit, but in my average week, I get about 15 to 20 articles, and some of those are more complex than others, and some of them take more time. So it is a significant investment. I argue that it takes, in addition to those 18 undergrads and 1 graduate student and about 40% of my time, that's not a trivial amount, but it's for 8 journals. So for a different journal with a smaller flow, it would take less resources than that. But divide what I just said by 8, and that's still a non-trivial aspect to it. Many of my colleagues at other journals are doing this with graduate students, 2 or 3 graduate students for a much reduced flow, or are not doing the full suite. So I know at least one journal is primarily looking at, does the README make sense? Does the code seem to be complete, but we're not running through all of that, right? So that significantly reduces the amount of time going through. Should it take as long as what we're doing, we could be, and we will be soon in the near future, be more prescriptive about what kind of information we're going to request from authors, but in particular in terms of how they describe what the processing should do, because we found that to be very important. We've been relatively hands-off initially, trying to figure out, should people get at that? And the vast majority do, but it's only a majority, it's not the bulk of them. And so there will be some additional guidance, but it won't be AEA specific. So we're going to be a collective of econ data editors who are going to determine some more prescriptive features of a replication package to make it ultimately be easier to replicate and to be more scalable.
Great, thank you.
Flora has posted another question about what if someone else than the author finds errors in data and code. I don't get involved unless that involves modifying the repository, and we have done that. And so in principle, the authors can release a new version. It's what I pointed out earlier. Think of it as a graph. There is one version, need not be the first. It won't be the last if there are errors in it. That is the one that's associated with the published article. And then you find a bug that we didn't find or that we couldn't find because we didn't have access to all the data. And then there will be a modified version potentially of the repository that says this is a post-publication modification that fixes an error that's in there. Right? That's one way of doing it. There's a traditional way, and I currently have in front of me a comment on an article that says the authors didn't do it right. Here's what it would be if they did it right, and their reply. And both the comment and the reply have their own data deposit. But those were created in a world where my policy wasn't yet in place. Whether that's the right way to go about it downstream is a different question, right? Would this be a version 2 of the original author's repository with a comment, etc.? That's still something that is not entirely clear. Right? I should note that the general question about should this happen more often, that actually authors come back and say, hey, I was pointed out to an error in my replication package and I'd like to fix it. The whole point of making these A, more findable, B, more transparent, and 3, pre-vetted so that there's at least a plausible chance that everything's there and can be run, etc., is to reduce the barriers to doing just that kind of vetting, right? We ran through all the things and it worked for us, but like I said earlier, we're not going to be the ones to check that you had the right option checked for the standard errors, or that you used the right technique, or when you said you used fixed effects, you didn't actually control for them, or things like that. We don't do that. That would be a far more intrusive, far longer way of doing it. I probably wouldn't be able to do that with undergraduates. It's not even clear that you could do that with graduate students, because that's the scientific discussion in part. You have to know what the right method is and then apply it. But it becomes so much easier to do that if you have a replication package that somebody says, in this case us, download it, run it, it produces results. Now you can take it apart and see if it's reproducing wrong results, right? And so the whole point is to reduce the barriers to making that kind of analysis. And by definition, we've made it so low that an undergraduate can run it. Now, do they learn with that? Do graduate students who are 2 or 3 years removed from being an undergraduate, can they start digging into it? Will this become part of an educational aspect? That's where what Fernando talked about in the earlier session comes into play. This is all about enabling that and reducing the cost to doing so.
Looks like we've got someone with a hand up, so I think you can unmute yourself and ask your question.
Sure, hi. This is Limor Pierre from Yale University. Lars, I'm wondering what kind of interactions you've had with the universities, with the institutions themselves. Have you heard feedback? Are they happy about these efforts? Are any universities doing these sort of things on their own? Including, I'm curious about any kind of cost sharing.
Very interesting question, and so far, no. Absolutely no interaction with universities. I would have been surprised had I had that, because most researchers submit to journals completely independent of what their university thinks about this. Clearly, being at Cornell, your colleague at R² have been part of this, of implementing such institutions at universities, and they are producing pre-publication, pre-submission vetting of that, and your team at Yale as well. But we have yet to see that intersect with what we see at the AEA. I don't know about my other colleagues at some of the other econ journals. I work closely because we're for the confidential data with the French Cascade service that you're probably aware of as well. And in a full year of doing this, we have just now had our first paper come across my desk where I can use their service to do the vetting on the confidential data. But those authors did not avail themselves of Cascade's offer to do pre-submission vetting of the package as well. My guess is that simply most of these papers were in the pipeline before we started to put the service in. And so there is some of the papers that I've seen were submitted in 2015. That's rare, but that is still possible. And so it'll take some time before people start to make the connection of, I could actually use a university service for this, and then show to Lars at the AEA that he doesn't need to do this stuff. We've already done it. And I'm looking forward to having the opportunity to explore that. We will want at that point in time, and that's been discussed a few times elsewhere, about how would you actually go about vetting that the vetting was done right. That's still something where we have some progress to make, because it's at this point in time pretty uncharted territory, because we haven't seen that intersection. My hope is that I will get a lot of those, because that is, like you said, much cheaper for us. It's cost sharing because the university will have done part of that. But it doesn't require just that. It requires the authors to be aware of that and then look around for the resources, whether it comes from research groups. There are some research groups that do vetting for their researchers as a service. I occasionally work with JPAL. They have done that in the past, but they don't continuously do that. I3E does it. They've had incentives in the past to produce reproducible stuff. And I have seen some that have gone through some level of, we're going to create a reproducible archive. And there's some very interesting interactions between what's reproducible within a lab may not be reproducible outside of the lab. And so creating a reproducible archive is still not necessarily always well defined. To figure out what others have succeeded in replicating or reproducing, certifying that and providing us with that, I have yet to encounter that.
Thank you.
Okay. Okay, if we don't have any further questions, I don't see any hands. I don't see any further questions.